Okay, so this unit is going to be on rational expressions. We've studied something similar to rational expressions when we studied polynomials. Polynomials had just numbers and variables combined with addition and subtraction, and rational expressions are really similar in the sense that they contain polynomials, but they are always fractions. So in a rational expression, you're going to see a numerator and a denominator, and you'll have a polynomial in both the numerator and the denominator. So that's what we're going to be seeing a lot of. As you kind of look at these examples, the question is which of the following equals 5. You can see in part D that the 10s cancel out. When those cancel, there's just a 1 left in the numerator. So that would just be 1/5. That one does not equal 5. If you look at part C, the 3's cancel, so that is equal to 5. So C would be an answer to this question. If you look at part B, 4 is alone in the numerator, but 4 plus 5 is 9. So 4/9 is not equal to 5. B would not be an answer to this question. And in part A, the most common thing to want to do is to cancel out the 2's, but you actually cannot cancel those. If you think about adding 2 plus 5, you get 7 over 2, which is obviously not what you would get if you tried to cancel the 2's. If you did cancel the 2's, you would get 5. And that's the biggest mistake that people make in a unit like this, is thinking you can cancel those 2's. So let's kind of learn about why. Probably the most important thing you need to know in this unit is that if the numerator and the denominator share a factor, remember factor means that there's been some kind of multiplication occurring between two terms. If they share a factor, then you may cancel it out. So for example, 2 is a factor in both the numerator and the denominator here. It's a factor because it's being multiplied, so we're allowed to cancel those out to just 3. So basically, you can cancel when there's multiplication. If not, though, you cannot cancel. So again, you cannot cancel these 2's. If you did cancel them, you may think that the answer is 3. Oh no. But you can see by adding the numerator together, you would end up with 5/2, which simplifies to 2.5. That is not what you would get if you canceled the 2's. If you incorrectly canceled the 2's, you would get 3. That is not the same thing. So you cannot cancel when there's addition. Or subtraction, really. I hope you're writing this down. These would be really powerful notes to have. So you can cancel when there's multiplication. You cannot cancel when there's addition or subtraction. To kind of illustrate this point, you can see that in this, like with numbers, so like these are all basic things I would expect you could simplify. But for example, in the first one, 6 and 6 are in the numerator and the denominator, so they are allowed to cancel. Another way to think of 6 would be as 2 times 3, and another way to think of 9 would be as 3 times 3. So as you're looking at these factors, we can see that the common factor would be 3, so the 3's can cancel, and this fraction simplifies to just 2/3. 27 and 63 are similar. 27 is the same thing as 3 times 9. And 63 is the same thing as 7 times 9. So as we look at these factors, we see that the 9's cancel, so we would be left with just 3/7. So again, because there's multiplication, we can cancel. However, in this next fraction, we cannot cancel the 6's because of that addition. So canceling here would be incorrect. We simply can add the 6 and the 5 and simplify this to 11/6. But no canceling can occur. Same thing in the second example. We cannot cancel because of the subtraction in this problem. We can only cancel with multiplication. If we subtract 12 minus 9, we get 3, and then we can simplify in this way, but we cannot cancel here. So 12/3 would actually be just 4, which would not be what we got if we thought we could cancel. Let's start looking at some actual rational expressions now. So here we're looking at polynomials in both the numerator and the denominator. Remember, that was our definition of a rational expression. So as we look for common factors, we know that 12 is the same thing as 3 times 4. So when I want to cancel, I notice that the 3's can cancel, and I would be left with an x on the top and a 4 on the bottom. So this rational expression would simplify to x over 4. Similarly, in 15 over 12, we know that 15 is that 3 is a common factor in both 15 and 12. So if we divide both of those numbers by 3, we're left with a 5 and a 4. And then we can think about the x's. When we studied exponent properties, we talked about writing x to the third as x times x times x, occurring 3 times. X to the 8th would mean 8 x's. 1, 2, 3, 4, 5, 6, 7, 8. So as we look at factors that cancel, 3 of the x's can cancel, but nothing else can. So we could write this as 5 over 4 x to the 1, 2, 3, 4, 5. There are 5 of them left over. Remember that the exponent property also states that you could just subtract these exponents. So 3 minus 8 would give you a negative 5. Since it's negative, that means that those 5 go in the denominator. So 5 over 4x to the 5th would be the complete answer on that. For the last example, 25 is the same thing as 5 times 5, xy to the 8th. And then in the denominator, 35 is the same thing as 5 times 7, x to the 7th and y squared. So as we look for common factors, we can see that the 5's can cancel because there's multiplication. So we would be left with just 5 sevenths. When we look at the x's, we have x to the 1 on top. So that means 1x can cancel from both the numerator and the denominator. There would be none left on the top, but 6 of them left on the bottom. So we could write that as x to the 6th. For the y's, similarly, only 2 of them may cancel, so there'd be none left on the bottom and only 6 left on the top as we subtract 2 away from 8. So the final answer here would be 5y to the 6th over 7x to the 6th. The next ones are a little bit more difficult just because they do have addition and subtraction in them, and earlier we stated that you cannot cancel with addition and subtraction. However, these are in factored form, which truly means that multiplication is happening between these factors. Remember, when multiplication occurs, we may cancel factors. So if you want to cancel expressions with pluses and minuses, it's helpful to factor first so we can cancel out factors. It's very simple here. We see that we have an x plus 3 in common, so this would simplify to just x minus 2. In the second rational expression, the x minus 1's may also cancel. Notice that there's nothing left on the top, so we just put a 1 there, because x minus 1 divided by x minus 1 would just be 1. In the denominator, we are left with an x plus 2, and that would be your final answer. So these examples, as you can see, have not completely been factored yet. If you notice, the denominator of the first one still has subtraction without any kind of multiplication occurring. So if we rewrite this expression, the numerator is completely factored, so there's nothing more we can do to factor that. We could factor out a 2 in the denominator, though. So if I factor out a 2, remember that means I'm essentially dividing both terms by 2. I would be left with x minus 3. And then this has multiplication occurring between every factor, so now we may cancel things. But only when you have an expression in factored form can you cancel things. So we may cancel out terms now. I can cancel the x minus 3's that we have in both the top and the bottom, and the 2's that we have in both the numerator and the denominator. So we are left with just x plus 5, as there is nothing left in the denominator. The second example may require us to do some factoring first. So remember, we're looking for things that multiply to be, I suppose we could factor out a 3 first. Let's try that. So if we factor out a 3 first, the greatest common factor, we'd be left with x squared minus x minus 6. And the denominator, we can also factor out a 3. So we're left with x minus 3. The top, or numerator rather, is not completely factored because x squared minus x minus 6 is still factorable. Keep in mind we would be looking for things that multiply to be a negative 6, that add to be a negative 1, because the b value of this quadratic is negative 1. As we think about numbers that multiply to be negative 6 and add to be negative 1, I think that negative 3 and positive 2 would be those numbers. So this expression factors to x minus 3 and x plus 2. Now keep in mind we still have the 3 in the numerator, and then we have all of the denominator left. So we can just copy those over. And then we see some really great canceling occurring. The 3's occur in both the numerator and the denominator, so they may cancel. And the x minus 3's similarly may cancel. So we are left with just an x plus 2, as nothing is remaining in the denominator. I would love for you to take a moment and try these next ones on your own. Remember that you must factor first and then continue from there. So go ahead and pause this video right now so you can see the problems still on the screen, practice a few of them, and then press play and you'll be able to see the answers. Go ahead and pause this video now. Okay, so at this point you can see the answers. I think on number 3, you may have needed to show some extra work to complete those factorings. And on number 4, a really common error is that when you see that the x plus 4's cancel, to just say that the answer is 3x minus 1. But keep in mind, the 3x minus 1 is in the denominator, it needs to stay there. So that leaves just a 1 in the numerator. As we look down at the other practice problems, I think most of those were pretty straightforward, but number 12 had negatives in front of the x squareds. So the first thing I did was to factor out a negative from both of those. So when I did that, I was left with an x squared minus 16, which is a difference of squares. So that led me to x plus 4 and x minus 4. And the denominator, when I factored out a negative, I was left with x squared plus 9x plus 20. So I was just looking for numbers that multiplied to be 20, that added to be 9, and I decided on 5 and 4, which is where my x plus 5 and my x plus 4 came from. So then the negatives could cancel and the x plus 4's could cancel, and I was left with just x minus 4 and x plus 5. A lot of people ask me about putting parentheses around those. You certainly can. I would never count you off for putting parentheses around those, but you don't necessarily need them either. So you could just leave it with no parentheses, or you could put parentheses around it. That's completely your call.